All right, let's jump right in. Today in this explainer, we're taking a completely inside-out journey to explore the immense scale, the underlying structure, and some of the absolute biggest mysteries of our home galaxy, the Milky Way. We are going to look at where we actually sit in this massive universe.
And to set the stage, let's borrow a line you might have heard before. Our galaxy itself contains 100 billion stars. It's 100,000 light-years side to side. I mean, those numbers instantly set some awe-inspiring stakes for us, right? This is not just a random scattering of lights up in the sky. It's a colossal, highly dynamic system, and we are just one tiny, tiny part of it.
Section 1. Our view from inside.
Before we can even begin to map this massive structure, we have to tackle a really fundamental challenge. You know when you look up at the night sky from somewhere super dark, like Mauna Kea here on Earth? We see the Milky Way as this glowing band. But because we're actually stuck inside this vast disk of stars, we can't see the big picture. That dark, murky interstellar dust literally hides most of the galaxy from our view. It's kind of like trying to map an entire sprawling forest while you're standing smack in the middle of the thickest part of the woods.
So what do we do? Well, scientists had to get clever. They shifted the type of light they observe. By looking in infrared light, which perfectly passes through all that pesky interstellar dust without being absorbed, the dust effectively becomes transparent. And boom, it affords us this glorious, unobstructed, all-sky view of the entire galaxy, where its true, magnificent shape finally starts to reveal itself. Section 2. Mapping the Milky Way.
Okay, so now that we've broken through the cosmic dust, we can actually map the whole shebang. We can succinctly break the galaxy down into 3 primary structural parts. You've got the central bulge, the flat disk, and the surrounding halo.
Imagine looking at it perfectly edge-on. Right in the middle is that bright, super thick concentration of stars. That's the central bulge. Extending horizontally outward from there is the thin, flat disk. And then encompassing the entire thing, almost like this faint spherical bubble, is the halo. And that right there is the basic architectural blueprint of our galactic home.
Section 3. The scale of space.
100,000. I really want to let that number sink in for a second. The Milky Way is 100,000 light-years wide, side to side. That means it would take a beam of light moving at the universe's ultimate speed limit 100 millennia just to cross from one edge of our galaxy to the other.
To kind of anchor us in all this mind-boggling space, let's have a quick "you are here" moment. We definitely do not sit in this center, but we aren't on the very edge either. We sit roughly 28,000 to 30,000 light-years away from the galactic center. And out by us, in our solar neighborhood, that flat disk is only about 3,000 light-years thick. So we're essentially just riding along in this relatively thin spiral arm, endlessly orbiting that distant bright center.
Section 4. 2 generations of stars.
Now, this vast space isn't just a random scattering of identical cookie-cutter stars. It actually contains very distinct generations. Astronomers basically categorize them into 2 main camps. Population-ized stars are the ones found in the disk. They're relatively young, up to about 10 billion years old. They have higher amount of heavy metals, and they move in nice, orderly circular orbits. Then you have population-2 stars living in the bulge and the halo. These are the ancients. We're talking 10 to 12 billion years old. They have far fewer heavy metals, and they move in completely random, chaotic orbits.
You can actually see this contrast visually when you look at star clusters. The open clusters that we find in the disk represent those younger, orderly population-ized stars. But out in the galactic halo, that's where you find globular clusters. These are ancient, incredibly dense spheres of population-2 stars, just swarming in random orbits around the center. They are literally like cosmic fossils. So why does this demographic data actually matter to us? Well, it acts as a historical record. Because those older halo stars have random orbits and fewer heavy elements, it points to a really violent beginning. It tells us the Milky Way likely existed as several distinct, smaller galaxies that smashed together and merged long before our organized, orderly disk of younger stars ever even formed. We are living inside a merged giant.
Section 5. The unseen dark matter. Okay, let's pivot and look at how all this mass actually moves.
Think about a standard planetary system, like our own solar system. Because most of the mass is concentrated right in the center with the sun, planets further out orbit much, much more slowly. So logically, based on all the visible light and mass concentrated in our galaxy's bulge, we would expect the exact same thing for the Milky Way. The outer edges should absolutely spin more slowly than the inner parts.
But here is where the universe throws us a massive curveball. To quote our sources, yet when astronomers took additional measurements, what they found completely defied all expectations. The outer edges of the galaxy aren't slowing down at all. They are spinning incredibly fast. In fact, they are spinning way too fast to be held together by the gravity of the stars and gas we can actually see. By all laws of physics, the galaxy should literally be tearing itself apart right now. The only way to explain this mind-bending rotation is that there simply must be more mass pulling on those outer stars, mass that we cannot see. The inescapable conclusion here is that this entire vast pinwheel of stars and gas is actually turning within an enormous, massive cloud of invisible matter. It doesn't interact with light, it doesn't block light, but its gravitational pull is absolutely immense. We call it dark matter, and believe it or not, it makes up the vast majority of our galaxy's total mass. We mapped the bulge, the disk, and the halo today, but it turns out all of that visible beauty is just a tiny fraction of the total picture. Which leaves us with a pretty profound realization about our cosmic home. If most of our own galaxy is completely invisible to us, what else is hiding in the dark?